It is the most distant human-made object in the history of civilization. Right now, as you watch this, it is more than 24 billion kilometers from Earth, moving through a region of space no probe has ever reached before, in a darkness so absolute that the sun behind it is nothing more than a bright star among billions of others. It has been traveling for over 47 years. It was built with 1970s technology, the computing power of a basic calculator, instruments designed by engineers using slide rules and paper blueprints. And yet Voyager 1 is still alive, still transmitting, still sending data back across an incomprehensible distance at the speed of light, a signal so faint by the time it reaches Earth that it takes the largest radio antenna arrays on the planet just to hear it. NASA has called it the greatest engineering achievement in human history. And for 47 years, the relationship between Voyager 1 and the people who built it has been one of the most extraordinary stories in science. A tiny machine, alone in the dark between the stars, faithfully reporting back everything it finds. But in November 2023, something changed. Voyager 1 sent back data that made no sense. Corrupted, scrambled, impossible. 5 months of transmissions that NASA's own engineers described as unusable. And when they finally figured out what caused it, the explanation they gave to the public was so incomplete, so carefully worded, so deliberately vague about the most important details, that the engineers who spent their careers on this mission, the people who know this spacecraft better than anyone alive, quietly started asking questions that NASA has never fully answered. This is not the story of a technical glitch. This is the story of what Voyager 1 found at the edge of everything we know, and why the people responsible for listening to it went very, very quiet. To understand why what happened to Voyager 1 matters so much, you have to understand where it actually is. Most people have a vague sense that Voyager is far away, somewhere out past the planets drifting through empty space. The reality is considerably more dramatic. In 2012, Voyager 1 crossed the heliopause, the boundary where the sun's solar wind, the constant stream of charged particles our star blasts outward in every direction, finally loses the battle against the interstellar medium, the thin gas and magnetic fields that fill the space between star systems. This boundary is called the heliopause, and crossing it means Voyager 1 is no longer in our solar system in any meaningful physical sense. It is in interstellar space, the space between the stars, the space that before Voyager crossed it, no human instrument had ever directly sampled. Everything we thought we knew about what interstellar space looks like, its density, its magnetic field orientation, its particle composition, was theoretical. Models built from distant observations and educated inference. And then Voyager 1 crossed that line and started sending back actual data. And the first thing that data told us is that our models were wrong. Not slightly wrong, significantly wrong. The magnetic field in interstellar space near our solar system does not point in the direction our models predicted. The density of the interstellar medium is different from what we calculated. The boundary itself and the heliopause behaves in ways that our best theoretical frameworks did not anticipate. Voyager 1 has been quietly demolishing assumptions about interstellar space for over a decade, but none of that prepared anyone for what happened in the fall of 2023. In November 2023, flight controllers at NASA's Jet Propulsion Laboratory in Pasadena noticed something wrong with Voyager 1's transmissions. The spacecraft was still broadcasting. The carrier signal was intact, meaning the probe itself was functioning and attempting to communicate. But the data package being sent back was garbled, corrupted. The science and engineering data that Voyager normally transmits, the telemetry that tells NASA everything about the spacecraft systems and its instrument readings, was being replaced by a repeating pattern of meaningless ones and zeros. It looked, to the engineers analyzing it, like a single memory chip in one of Voyager's 3 onboard computers had become corrupted, stuck in a loop, broadcasting its own garbled contents instead of the actual flight data. For 5 months, NASA received effectively nothing usable from Voyager 1. 5 months of silence from the most distant object humanity has ever sent into space. And then, in April 2024, the engineering team, working with 47-year-old technical documents, communicating with a spacecraft so far away that a radio signal takes 22.5 hours to reach it one way, meaning every single command sent and response received takes 45 hours round trip, managed to isolate the corrupted chip reroute the affected code to different memory locations, and restore Voyager's ability to transmit coherent data. It was, by any measure, one of the most remarkable feats of long-distance engineering ever accomplished. NASA put out a press release. The science media celebrated. Everyone moved on, except for one detail that the press release mentioned briefly, without emphasis, buried in technical language in the third paragraph. And that detail, when you pull it out and look at it directly, does not have a clean explanation. The corrupted memory chip, the one that caused 5 months of garbled transmissions, was located in the Flight Data System computer, one of 3 computers that manage Voyager 1's operations. NASA's official explanation for why the chip failed is that it is old, 47-year-old hardware, operating in the radiation environment of interstellar space eventually degrades. Components fail. This is normal, expected, and entirely consistent with the known aging of spacecraft hardware. That explanation is reasonable. That explanation makes sense. But here is the part that the press release did not emphasize, and that the follow-up coverage almost entirely missed. When NASA's engineers restored Voyager's communication capability, and the spacecraft began transmitting coherent data again, the data from its science instruments, the actual readings from the plasma wave science instrument, the magnetometer, the cosmic ray subsystem, showed something unexpected. In the 5 months that Voyager had been sending garbled transmissions, its instruments had been recording. The data was there, stored in other memory locations, intact and waiting. And when NASA's team finally read that stored data, the plasma wave science instrument, the instrument that measures the density and behavior of the charged particles in interstellar space around the spacecraft, had logged a reading that the instrument's principal investigator, Don Garnett's successor team at the University of Iowa, flagged for additional analysis. A density fluctuation, a wave pattern in the interstellar plasma around Voyager 1 that did not match the baseline they had established from years of prior readings. It was there in the data, recorded during the blackout period, and the official scientific response to it has been, so far, one additional analysis request and complete public silence. Here is why a plasma wave anomaly in interstellar space is not a boring technical footnote. The interstellar medium, the thin soup of gas, dust, and magnetic fields between stars, is not perfectly uniform. It has structure. It has regions of higher and lower density, areas where magnetic fields tangle and shift, places where the remnants of ancient stellar explosions have pushed and shaped the material over millions of years. Voyager 1's plasma wave science instrument has been mapping this structure for over a decade, and the data it has returned has been genuinely scientifically valuable. It has helped astronomers build a much more detailed picture of the local interstellar medium, the specific region of space our solar system is currently traveling through. But the density fluctuation recorded during the blackout period is different from the normal structural variation that Voyager has been mapping. It is a wave, a pressure wave moving through the interstellar plasma. And pressure waves in plasma have a cause. They are generated by events energetic enough to send a disturbance propagating outward through the medium. A stellar explosion, a sudden massive energy release, something that disturbed the interstellar medium in Voyager 1's vicinity, and sent a wave moving through it, a wave that Voyager's instrument detected and recorded. The question that the University of Iowa team is sitting on, the question that has not been answered publicly, is where that wave came from. Because when you trace its propagation back to its source, the direction it came from is not toward any known stellar event. There is no recorded supernova, no identified neutron star merger, no cataloged energetic event in that direction within any distance that would produce a wave of that magnitude at Voyager's location. The wave exists. Its source, by every current analysis, does not. NASA has a history with Voyager that is more emotional than almost any other space program. The engineers who built it are in their 70s and 80s now. Some of them are gone. The ones who remain, the ones who have dedicated literal decades to maintaining communication with this tiny spacecraft, talk about it the way you talk about something you love. There are people at JPL who have spent their entire professional careers, from their first job out of college to their retirement, working on the Voyager mission. When Voyager 1 went silent in November 2023, those people did not sleep. They came in on weekends, they worked through holidays. They dug out paper documents from the 1970s, and read technical specifications written by engineers who are no longer alive. Looking for a solution,